All right, so we're looking at the quotient rule of differentiation. We've got two examples here. Okay, we'll look at example one. We have 5 sine x minus 4 tan x divided by x squared. Right, so in the quotient rule, you're going to pick your f and your g. Okay, how you know you'll be using the quotient rule is when you are dividing terms. Okay, that's how you know that you use the quotient rule. You're just dividing terms. So in this case, our f is going to be 5 sin x minus 4 tan x. Right, so say f equals 5 sin x right minus 4 tan x, right? And our g is going to be x squared. So g, okay, g is going to be x squared. All right, so let's have to derive f and g. So we'll start with f. And I'm going to say f prime equals. Right, so we know the derivative of sine, okay, is cosine. Right, so we're going to have 5 cosine x. All right. Then we have to derive this x in here, okay? And the derivative of x is 1, so you just say times 1. All right, the derivative of x is 1, right? Then you say minus, right? Minus, right? We have 4 tan x here, right? The derivative of tangent is secant squared, all right? So we'll say minus 4 secant squared x. All right, secant squared x times, we have to derive this x here, all right? The derivative of x is 1, so it's a times 1, all right? So when we multiply these ones, okay, 1 times 5, we're going to just remain with 5 cos x minus 1 times 4, remain with 4 secant squared x, all right? So that is our f prime. Then we go to our g prime, we derive g. Okay, we have to derive x squared. So the derivative of x squared is 2x. Okay, derivative of x squared is 2x. All right, so now that we've got our f and f prime and g prime, we just have to substitute it into the formula here. All right, so it's going to say, I'm going to say this equals, all right, so our g is x squared. Okay, g is x squared. Remember, we have it's g, right, multiplied by f prime. Our f prime is, so we're just going to open brackets, okay, and open brackets here. F prime is going to be 5 cos x. Five cos x Okay, 5 cos x minus, oh, here someone come in, right? Minus 4 secant squared x, right? So we've stated our g and f prime, all right? Then we're going to say minus, okay, minus, let me close the brackets here so that, right? So now we're going to list our f, okay? F is 5 sine x minus 4 tan x, right? And our g prime is 2x, okay? So we can put the 2x in front so that it looks neat, all right? So we'll start with our g prime. We'll just put g prime first here, 2x, okay? This is g prime. Then let's put our f, okay? Our f is going to be, open brackets, 5 sine x 5 sine x minus 4 tan x. Oops, I hope it's clear. Yes. All right. So we've listed our numerator on top there. Okay, we got x squared, open brackets, 5 cos x minus 4 secant squared x. All right. Minus 2x, open brackets, 5 sine x minus 4 tan x. All right. And then at the bottom, all right, we have to put g squared. Oops. At the bottom, we have to put g squared. So our g is x squared. Yeah, our g is x squared. And we have to square this. All right. Then to we simplify this, so we're going to say 2 times 2, all right? We multiply these exponents together, all right? And an exponent is raised to another exponent, you multiply them. So 2 times 2, that is 4. So we remain with x to the power 4, right? X to the power 4, right? And so this is our answer. Okay.
Excuse me, sir. How did you get x to the power 4?
I said since g is x squared, okay, g is x squared, and in our formula here, we have to put a g squared. So you're going to have,
Okay,
yeah,
okay, okay.
all right. Okay, we can go to the second one. If are there any queries on this one?
Sir,
Mm-hmm.
hello.
Yes.
So when these questions come, do they specify that find this question? When finding this question, is how do you know that this is a coefficient? Is it coefficient?
Quotient rule.
Quotient rule.
When you're
How,
just
how do you know?
when you are
How do you know that you have to apply the quotient?
when you are dividing two functions, f and g. Okay, when you're dividing two functions. Okay.
Okay, sir.
Yeah. x. Okay, maybe we can move on. We go to question 2. Okay, we have 3x squared divided by sine 2x. Okay, so as always, we state our f. Okay, and our f we say it is 3x squared. Okay, f prime. Okay, we derive 3x squared, right? 2 times 3, that is 6, right? And then this x squared, we subtract a 1 from this 2 and remain with x to the power 1. So we've derived 3x squared, right? The derivative is 6x. We pick our g. G equals sine 2x. Right, then g prime, right? The derivative of sine is cosine, so it's a cosine 2x, all right? And let's not forget to derive the 2x too, all right? This 2x here, we have to also derive it, right? So the derivative of 2x is 2, right? The derivative of 2x is 2. So I remain with, if we put it, if we arrange this answer, we'll say it's 2 cos 2x. All right, so now we can apply can put this into as the formula states, all right? We're going to start with g, all right? G, what is g? G is sine 2x. G is sine 2x. F prime is 6x, so we put 6x minus, all right, our f is 3x squared, and our g prime is 2 cos 2x.
That is for the denominator, sorry.
Numerator.
Oh, yeah, you're differentiating for the numerator. Okay.
Yes. 2 cos 2x. Now we see we have a 2 here and a 3, so we can multiply this 2 and 3. Okay, we have a 2 and a 3 here. All right, so we say 2 times 3, that will give us 6. All right, this 3 here, we'll multiply it with this 2. All right, and we're going to get 6. Okay, we're going to get 6. So we're going to write 6x squared 6x squared cos 2x. All right, let me just bring the cos. Let me write the 6x squared close to the cos 2x so it looks combined. All right. Okay, 6x squared cos 2x. All right, so that's our numerator. All right, that's our numerator. All right, then now in our denominator, all right, it's g squared. All right, our g is sine 2x, so we have sine 2x, all right, squared, all right, sine 2x squared, all right. You can also write it like this, all right. This sine 2x squared, you can also write it like this, sine squared 2, all right, sine squared 2, all right. They both mean the same thing, all right. And that is our answer.